So welcome to projectile motion. In this video we'll look at the definition of projectile motion, some of the uses and the equations, and then I'll go through an example. So projectile motion is a special case of two-dimensional motion in which the objects behave as projectiles. So for example, a cannonball being fired, or in this case, an outsized tennis ball being thrown. And the first condition of projectile motion is that the objects have an initial velocity in the x direction, but no acceleration. So the velocity in the x direction is constant. And that holds for the whole flight path. And the second condition is that there is an acceleration in the vertical direction, and that's due to gravity. And again, that's also constant for the whole flight path. I will note here that one of the major sources of error in projectile motion questions is misplacing the negative sign, or getting confused with which direction is negative. So when I'm dealing with projectile motion, I will always make down negative. So we see that in this case, I make the acceleration due to gravity negative 9.81 meters per second. So with these conditions, we can then find out our equations of projectile motion. So we said it was a special case of two-dimensional motion. So we start with our kinematic equations that we've derived in previous videos. And because we're working in two-dimensional motion, we split those equations into the x and y components, again, as we've done previously. In this case, we take it one step further. We apply the two final conditions of projectile motion, so zero acceleration in the x direction and acceleration due to gravity in the y direction. And that gives us the equations of projectile motion. So we don't need to memorize these, we can work them out straight from our standard kinematic equations. Before we go into the example, I thought it would be nice just to go through a few examples of situations in your life where you would be extremely pleased that you'd learned projectile motion. So for example, if you're ever in the situation of calculating where you need to launch a missile from and at what angle, or if you're fighting a bushfire or fertilizing a field, then where you release your fire retardant from, so how far from the fire and at what height you fly your plane, they will be determined by projectile motion. So it's probably slightly more useful than the missile. Or if you have leanings towards becoming a stuntman, the speed and the angle that these guys need to take off from to do their insane stunts is all calculated by projectile motion. Hopefully correctly. And finally, and maybe somewhat surprisingly, but if you are looking towards writing software to do with either animation software or things like flight simulation software, you will be using projectile motion. So now we can move on to our lovely example. So here we have an example of a plane dropping a parcel to a mountain village. We have details of the plane's flight, and we're asked how far from the village must the pilot release the parcel, and what the velocity of the parcel is when it hits the village square. So, step one, we draw our diagram. And then we ask, well, what are we actually looking for? So in the first part of the question, we want to find how far from the village that parcel must be released. So we're looking for Sx, for the displacement in the x direction. And what we have is we have the initial velocity and therefore the final velocity in the x direction. And in the y direction, we have our displacement, our acceleration, and also our initial velocity. And I will just point out again that I've made down negative. Part 3 then is choosing which equations to use. So the first one we're looking for is the displacement in the x direction, and I will choose the simplest equation to find that, which is just the velocity times the time. Here we don't have the time, so then we need a second equation so that we can find the time. And again, I'll just use this one because I know that we have all of the quantities. Fourth is solve. So I take my second equation and I find t by substitution. Note again that both my displacement and acceleration are negative, and I find that I have a time of flight of 9 seconds approximately, and then I can substitute that value into my equation to find the x displacement. So we know the pilot has to release the parcel at about 500 meters before the village. Part 2 of the question, it asks us for the velocity of the parcel when it hits the village square. So I would assume that just before it hits the village square is probably better wording. So again, we draw our diagram. We know that our parcel has an x component, because it was released when the plane was moving with the velocity in the x direction. So it has an initial x velocity, and we know it has a y velocity because it's falling. So we have, again, the same as last time, the velocity in the x direction, and we've now worked out the displacement in the x direction. We have all of our y variables as last time, and we also have the time of flight. So then step 3 is to pick our equations. So to find the parcel, we need Vx and Vy. We know that we can find Vy just from the initial y velocity, the acceleration and the time, and we know that our x velocity is equal to the initial x velocity, which we have. So once we have that, we just need to solve. So to find Vy, it's just a matter of substitution, and again we see that we get a negative velocity, which is good because we were expecting that y is falling down, and we've made down negative. And the second half of the equation, of the solving it, is to find the velocity of the parcel, and we do that by vector addition. So I will leave that with you as a problem, but I will also give the solution in the video of the tutorial solution.